Yeah. Okay, everybody. Our next presentation is titled "The Promises and Challenges of Crypto AI Applications," and the keynote speaker really needs no introduction. He is one of the foremost thinkers in the entire industry. We are extremely privileged to have him joining us for this keynote. Please welcome, by the magic of the internet, Vitalik Buterin.
Hello, guys. Yeah, it's lovely to virtually see all of you. So crypto and AI is wow. Okay.
They can't hear him on the speakers.
You cannot hear me still? 1, 2, 3, 4, 5, 6, 7, 8.
We can hear you now.
Okay. Perfect. So in the intersection of crypto and AI is this topic that, like, I personally have been hearing a lot of interest in for pretty much all of the past 10 years. Right, crypto, it has been a major field of computer science for quite a long time, and of course, blockchains and cryptocurrencies have really supercharged it a lot. And AI, at the same time, is a major field of computer science, and over the last couple of years, in particular, it's just massively impressed basically everyone in terms of the amount of progress that it has made. And so the intersection of crypto AI, trying to figure out like which kinds of applications that use both of those technologies make sense, is something that a lot of people have really been thinking about for a long time. But like, it's also one of those areas where it feels easy to kind of come up with like these very like a vibe level, like very abstract correspondences between the two. But it's much harder to figure out like what concrete intersections between those two technologies actually work in practice, right? So one of the things that I usually show for this is if you look at this slide from the UETH website on synergies between blockchains and artificial intelligence, right? It basically it lists some common features of AI, including some actual weaknesses of AI, and a little bit some strengths of it shows some strengths of blockchains. Basically, AI is centralized and non-transparent, and blockchains are decentralized and transparent. AI has big monopolization tendencies. Blockchains are all about empowering the little guy, and shows some synergies between the two, right? And I think like these kinds of very abstract synergies are something that a lot of people have talked about, right? So like I think like both Peter Thiel and lots of other people have talked about this idea that crypto and AI are the two defining technologies of our time, and AI is a centralizing force, and so crypto is a decentralizing force. And from a narrative perspective, like this makes a lot of sense, and like you can see the argument for how the existence of AI makes it even more important to keep pushing harder on the blockchain and cryptography direction. But what's harder to see is like how this actually translates into applications that actually use both, right? So, like, are crypto and AI doomed to be like completely separate spheres, or are there actually applications that make sense that actually manage to leverage the synergies of both of these things together? So, 4 major categories, right? So, this is the categorization that I've come up with. Basically, AI as a player in a game. So, a blockchain sets up a game, and AI is playing that game. AI as an interface to the game. So AI is helping people to understand the blockchain world and navigate it more easily and more safely. AI as the rules to the game. So AI is actually being critical components in things like DAOs, on-chain courts, various kinds of Oracle arbitration and enforcement mechanisms, and AI as the objective of the game, which is using blockchains and DAOs specifically as a mechanism for collaboratively building AIs that are more open and democratic in some way. So like the last one especially, I mean, I know Ilya from Mir has been a huge fan of this category, and I know various people have been interested in a lot of these. So I'm going to go through all of these in turn and just talk about like where I see the viability and where I see the risks. So AI as a player in the game, right? So AI as a player in the game is actually an AI crypto intersection that has existed for like basically a decade, right? Like we don't normally think of it as an AI crypto intersection because it just feels like so kind of a little bit lame and unimpressive, but it is, right? And that basically is automated market maker bots, right? Every exchange, centralized and decentralized, it ends up getting professionalized market makers, and those professionalized market makers end up being run on AI algorithms. And now we have the MEV space, and that has just made the game even more complicated. And sometimes you have MEV bots that are exploiting each other. You have sandwich attacks. You have counter sandwich attacks, like sandwiches of sandwiches. You have various attempts of arbitrage bots to exploit each other and like trick each other into giving each other free money. There's all of this really complicated AI playing games that we've been seeing in DeFi and CeFi for many years. Now, I actually view this as being only the first example of a much bigger category, right? And I think the natural second member that's really valuable here is AIs playing in prediction markets. So if we just scroll down here a little bit further, one second, sorry. There we go, right? So here we have AI Omen. So this is a demo of AIs playing prediction markets. So here you see a bunch of prediction market questions. You know, will IRS successfully start the 2024 tax season? Will the Supreme Court make a decision? Blah, blah, will NVIDIA's RTX remix will be utilized? And basically what we see here is these are very micro scale prediction markets. Like this little market volume in this case is like 10 DAI. And then you see AIs actually playing in those markets, and AIs are the ones that are making the predictions, right? So prediction markets are something that has been actually picking up quite a lot of traction recently, right? So in 2020, we saw a lot of people betting on the election, and I wrote a big blog post analyzing it. Then, in 2023 and 2024, it feels like there's more and more of them happening, right? Like prediction markets were a big part of the story during the LK99 situation about half a year ago. They've been used to predict political events in all kinds of countries. They've been getting very mainstream, right? Like I saw Donald Trump actually retweeted some prediction markets on Truth Social. And just like very mainstream intellectuals are pointing to prediction markets as a source of information about various things and about like what kinds of things are likely to happen, right? And this is something that is growing on its own, which I think is like interesting to see. And like I personally continue to be excited about them because they're a way to, or they're a decentralized technology that can help us sort truth from BS and like figure out actual high quality predictions, but using a mechanism that is actually decentralized and that doesn't like privilege one specific class of experts. But at the same time, there's like the challenge that you need lots and lots of people to participate to really make them high quality, right? And so, what if robots can participate in prediction markets? That's the issue. And this is basically exactly what Omen is trying to do, right? There's other examples that are interesting, like what if you think of micro prediction markets, like you can imagine a micro prediction market on whether or not a particular DApp is legit, on whether or not a particular post on a particular social media platform, like complies with some particular set of terms of use, which or whether or not a particular token is legit, right? Like you can basically make all kinds of micro decisions into prediction markets, and you can have some kind of underlying like final adjudication mechanism that's determined by humans, which is important, but most of the time, you're basically able to scale up the trust in those humans by basically having a bunch of bots whose job it is to do the best job that they can of predicting them, and the ones that do a better job of predicting them get more money, and the ones that do a worse job of predicting them end up dropping out over time, right? So I think this is one of those really fascinating spaces that I'm excited about. Now, the second piece is AI as an interface to the game, right? So one of the things that we've been seeing in the past year is the growth of wallets that try to do more to protect the user and to give the user a clearer view of like what actually is going on in the network. So MetaMask has had a scam detection list for a long time. This is not an AI, it's just like a pretty basic list. The Rabby wallet has a transaction simulation feature, but so far these tools are very primitive, right? So like in this particular case, it's showing me that I'm selling 1,000 Bitcoin for 0.02 ETH, but what it's not telling me is that Bitcoin in this case isn't actually Bitcoin BTC. It's this meme coin that's called Harry Potter Obama Sonic 10 Inu, whose ticker symbol happens to be Bitcoin, right? So like an AI would actually know the difference between those two, and that's something that's important to highlight. But like a simple list doesn't, right? So you could potentially like really supercharge these kind of user protection tools and user convenience tools by using AIs, and like really help users get a much better understanding of what it is that they're signing on to when they sign in approval or when they put money into a DeFi protocol. So number 3, AI as the rules of the game, right? So this is one that I think gets a lot of excitement. So even in mainstream discourse, for example, there's been a lot of interest in this concept of AI judges, right? There's an article on the World Government Summit that's talking about it. And like, this is just a very popular theme that people like to talk about, especially back like 10 or 15 years ago. And like, especially, back in the day when people thought that AIs would be like kind of quote, culturally and politically neutral just automatically, as opposed to reflecting the perspectives of their creators and trading data, as we have seen a very fun demonstration of with Gemini over the past week. So there's a lot of people who have these similar desires in the context of blockchain applications, right? Basically, if you have a blockchain-based smart contract or DAO, what if you actually use some kind of AI to make the final decision about like subjective questions, right? So Optimism, for example, has like a natural language constitution called the law of chains. And like, what if you could actually have an AI interpret that constitution and interpret whether or not a particular proposal satisfies that constitution, right? So there's 2 challenges to this, right? One of those challenges is, as I mentioned, any AI is going to reflect the perspectives of the training data and the people who are creating and fine-tuning it. But the other problem is this issue of adversarial machine learning, right? Basically, the 2-sentence argument for why like these kinds of AI applications are really tough to get right is that if you have an AI model that's playing a key role in a mechanism and it's closed, then you can't verify its inner workings. And so it's not actually better than a centralized application. If the AI model is open, then an attacker can download the model and they can simulate attacks against the model locally. And they can develop heavily optimized attacks to trick the model that they can then replay on a live network, right? So over here we have an example of adversarial machine learning where basically someone essentially trains a kind of counter model where that generates a set of tiny changes to an image of a cat that when applied to a particular model makes the cat look like a dog to that model, right? And one of the challenges of adversarial machine learning attacks is that they work surprisingly well even when you don't have access to the underlying model, right? So like one of the things you might think about is like, oh, well, what if we do fancy cryptography to try to like actually hide the contents of the model, right? And like there are tricks to do that we'll actually talk about. But the problem is like, even if you do that, then there are these black box adversarial machine learning attacks where it turns out that if you make an attack that works against one model, then that attack often translates and like also works against other models that have been trained using similar training data, even if it's totally different parameters to do the same task. So cryptographic overhead, right? So the problem is that a lot of these general purpose cryptographic magic things that we really love to think about in Ethereum, they have very high overhead, right? So we're used to like ZK EVMs taking thousands of times longer to run than just a regular EVM, right? Geth can verify a block in like 400 milliseconds, but actually proving the block takes like 20 minutes and like with better hardware, right? And MPC potentially can be even worse. And then AI computation is very expensive, right? If you want to run a model locally, then like you basically need a GPU, right? And the difference between top of the line models and like weaker models is massive, right? And so basically the risk is like, is it the case that for any use case where you have a really powerful model that can run inside of a, or is it the case that for any model that's small enough that you can actually put it into a cryptographic black box, it's just much, much better to use a more powerful model where you just run it in a regular computer and you trust the operator? And like, is the delta in quality between the small one and the big one just kind of like so high that there's no point in even trying, right? Like if the overhead is 1000x, then the answer is yes, right? But I think what's interesting is that AI is a very specific type of computation that is amenable to all kinds of optimizations that unstructured types of computation like ZK EVMs cannot benefit from, right? Like the general intuition pump here is that cryptography works over math, right? And the more you have math that has structure, the more cryptography can take advantage of that structure and like basically run a bunch of things in parallel and get extremely high efficiency because it's basically running over the whole computation at the same time. So AI happens to be basically a matrix multiplication followed by a nonlinear layer that goes layer by layer, followed by more matrix multiplication, followed by another nonlinear layer, right? And the bulk of the cost is matrix multiplication. Matrix multiplication is linear, right? It's just a bunch of additions and it's a bunch of multiplications by publicly known numbers, which you can do with repeated additions, and so they're also additions, right? Or sometimes you don't do it like literally that way, but generally, yeah, both like multiplying by publicly known values and adding is very cheap to do inside of cryptography. So this you've probably heard of the same phenomenon in the context of homomorphic encryption. Additively homomorphic encryption is very easy. We've had it for 40 years, but like real homomorphic encryption that could do multiplication, we've only basically had it for the last 15 years even at all, and like the last 5 years in any viable form. So for ZK snarks, it turns out that you can potentially get a less than 4x overhead on the matrix multiplications. And for MPC, you can also get something similar, right? And the challenge is actually the nonlinear layers where the bulk of the overhead still is, right? But even still, the overhead of ZK snarking or MPCing AI is actually much lower than the overhead of doing the same for EVM computations. So actually putting AI inside of cryptographic magic boxes is like surprisingly viable, which is, I think, really interesting, right? Now, black box adversarial machine learning, right? Basically, the challenge is like, even if a model is hidden, if you even roughly know the training data that went into the model, you can often like basically make your own model, train attacks against your own model, and then those attacks also work against the original model. So if you want to effectively fight against black box attacks, you can basically like do two things, right? One is you have to really limit who or what can query the model, right? And blockchains are actually good for this because you can make a system where every single query that gets made actually has to be registered on chain. And then the second thing you can do is you can hide the training data, but at the same time use cryptography to preserve confidence that the process that was used to choose and use the training data was actually followed correctly, right? So basically, yeah, imagine you have this kind of game, right? Where the way that the game works is you have a bunch of users. Each of those users has the right to submit some portion of the training data, but the training data is encrypted, the training process is encrypted, then the model is encrypted, and then users have the right to make a limited number of queries against the model. And all of this happens in a way where the business logic gets registered on a blockchain. The computation happens with an MPC and with ZK snarks. And then if you do this, then you can actually have confidence that the method that was used to create a model was actually a method that is likely to generate a model that is actually fair and that actually does reflect the cultural like preferences of the community. And at the same time verify that like that model actually is the model that's being run. But at the same time, you hide the contents of the model, right? And so because you're hiding the contents of the model, like no one else can train attacks against it. Adversarial attacks are like a pretty big deal, right? So this is a fun one. Basically, someone made a wearable adversarial attack where you can basically wear this like special like crown on your forehead. And if you wear the crown, then like you end up from the point of view of facial recognition models, you either don't look like a person or you totally look like someone else, right? So they're a big deal. But the theory is, if you hide the model, you hide the training data, then you can actually protect against it. So cryptography plus AI to create these kinds of models is another one of those like super powerful things. And then finally, if you use these same methods, then you can use AI as the objective of the game, right? And this is basically using these kinds of cryptographic techniques to like actually create these like quote trustworthy black box AIs, basically AIs that can be owned and controlled by a community, and where the actual model is hidden, which means that which makes it safer to use the model for sensitive tasks. But at the same time, there is no like single player that is empowered to like have the backdoor keys and be able to see everything. And also from an AI safety perspective, this lets you create a decentralized AI that could have, like, for example, an on-chain DAO that's controlling a natural kill switch, or potentially even limit queries that try to use the AI for malicious behavior without actually requiring any kind of centralization. So a lot of really interesting possibilities. I think one note of caution here, of course, is that like these are things that are still like dependent on a lot of pretty intricate technology going well, right? So this is not the same as like stablecoins and NFTs where we've basically figured everything out and it's a matter of user adoption, right? Like this still is pretty speculative. Like whether or not someone can actually make this kind of pipeline work and actually be efficient enough, that's an open question. Whether or not AIs playing prediction markets can like actually outperform big AIs, it's an open question, right? But I do think that these things are actually interesting and these things are worth trying. And I do think that the underlying story that the default trajectory of AI is one that is going to be like both risky and empower all kinds of centralization risk. And this is this really interesting alternative strategy is one that is I think super interesting, right? Basically, crypto can both compensate for a lot of the challenges that AI creates, right? Crypto verification could be used to compensate for higher risks of AI deepfakes, for example. But at the same time, crypto can AI, I think, in a lot of cases, can actually work together. And I'm excited to see like what kinds of applications in these categories people can come up with.
So we were able to source a couple questions from Twitter X from those folks who were not able to attend in person. So the first question we have is, do you foresee a future where blockchains scale intelligently? And if so, what does that look like?
When you say scale intelligently, do you mean like scale using, I guess, like artificial or other intelligence, or do you just mean like scale in a way that makes sense?
The way that I'm taking this question is that they're scaling on their own via artificial intelligence.
Okay. I feel like, I mean, the way that I see the blockchain scaling landscape is that basically right now, we basically roughly know how to scale blockchains from a fundamental perspective, right? We know how data availability sampling works. We know how sharding works. We know how snarks work. We know how rollups work. We know how all the pieces work. And it's basically like a big implementation challenge to like actually spec out and build all these pieces and make sure that they don't have bugs, right? The place where I think AI can help in that process in particular is actually another application that I totally forgot to mention here, which is using AI for like bug catching and formal proving, right? Like, I don't know if people have been following this, but there's been a lot of progress in like better kinds of formal mathematical proving tools. Like Thierry Tao's been excited about Wien recently. People are trying to explore like, can you use AIs to try to generate proofs and then at the same time use these formal methods to verify those proofs and potentially even like run those two methods like very closely in parallel with each other. And if those methods become much more powerful, then you will be able to do things like, for example, proving that a ZK snark that is verifying ZK VM computation actually is verifying the same thing that is specified in, for example, the Ethereum EOL specification, right? Or verify that, like, for example, the Ethereum Merkle tree like actually is a consistent tree, it's order independent, and like all of the properties work the way that they're supposed to work, and that the proof system is cryptographically secure, right? Like, if you have much more powerful AI-based theorem proving, then it might actually be able to like prove these crazy complicated claims in a way that's just not possible today. So that I think is one area where kind of like artificial intelligence can like really heavily assist blockchain scaling, and I think that would pretty significantly change the landscape.
And then our last question, this person asked, there are about 4 or 5 large AI companies right now not leveraging blockchain. Do you think they'll ever start working blockchain into their models, into their platforms? And if so, in what ways do you see them leveraging the technology?
Yeah, it's a good question. I mean, crowdfunding model training, I think, is one of those that, of course, could be interesting. And like, that's something I know some people have been interested in, right? And like, the concept of like paying people for data, I've always been kind of like a little bit like skeptical of because it just feels like like the biggest, like 90% of the progress is coming from better computation and better methods, and not really better data, right? It often doesn't feel like data is the limiting ingredient, though it does seem from like the conversations I've had with AI people that like high quality data in particular is something that often is really valuable in getting a model to higher levels of performance at useful tasks. And so if you can make a pipeline where you can like automatically compensate people for submitting like verified data, then, and like I think it has to be verified because otherwise, like it's just going to become vulnerable to like poisoning attacks of the trading process. And then that's another thing that's potentially interesting. And then, like, if some of these distributed training and distributed inference ideas actually become viable, then, like, of course, that's going to be super cool as well. And there's like different ways to do that, right? Like you can run an entire training process inside of an MPC, as I talked about. You could do like some mixture of experts thing where you train different parts of the model separately, and then maybe you like do the MPC training process for like some top layer at the end. There's different ways to do it. So like actually, yeah, seeing some experimentation with that kind of stuff would also be interesting. But yeah, I mean, aside from that, I don't know, right? I think like the base case where you have these existing models that are just being given to people, made available for people to use in a very like centralized API based way, and where you have like much smaller models that people can run on their laptops is like that's getting pretty powerful and getting pretty entrenched, but like if crypto could also add some third category, it would be cool if it succeeds.
All right, that's going to do us for Vitalik's keynote. Vitalik, thank you so much for joining us. We appreciate you being part of this summit, and we'll be moving on to our next panel shortly. Thank you.